Hello and welcome. So I'm going to give a really quick example how this works. So here we've got our seeds. I'm just going to plant some. I'll skip to the end. I'm going to say I plant some tomatoes. So if you make track of the time, this is on my system clock. You can see it's about 5 minutes to 3. So I'm going to save this. I know that there's 6 stages to my plant, and to get to the very last stage it will take a full hour. So we're going to skip to about 20 minutes. So I'm going to go to my time clock. I'm going to change my time 16. I'm going to change that. Now if I press play, you see we've got saplings. So what's happened is the application has worked out the time from when we last saved to now. So I'm going to increase by another hour just to show you the full maturity. And sure enough, we've got full maturity. So what I'm going to do is I'm going to show you how I set the project up and how I've done the code. I'm not going to be typing any code out. This project will be put on GitHub to download. I recommend looking at it there. I've skipped lots of anchoring stuff. I'm not focused on that. I'm focused on the time for my last save. So let's exit out of this. The first thing I'm going to do is actually delete the data file. This way we're starting right from fresh. As you can see, it's empty. I'm going to leave it alone. So on the main scene, we've got a no 2D, we've got a grass texture, I've got a farm plot with these scenes on them, I'll go over them in a second. We've got a time label which is just linked to my system clock, we've got the seeds which is an option button, and we've got our button save. So we're going to go over the farm plots. So this is actually a sprite, not an animated sprite, however this is an animated sprite. Why we use an animated sprite is that the 6 stages of growth. And what I've done for each plant, I've got 6 frames, so you've got 0 to 5, which is obviously 6, and what I do is I never make these play, I just change the frame depending on the stage of our growth. I have the plant invisible by default. Let's go to the plant, and as you can see the plant is just an animated sprite. I've not put any code on there. So if you take notice of these names, when I first load up I populate the option button with the names. So what we're doing is when we save into our file, we're just saving the name and we can apply that to the animation of the plant. So let's look at the plot. First thing you'll notice is in the node in the groups, it's very important, I've got plots. I can loop through plots groups and find every single plant I have. I've heavily commented the code so it's really easy for beginners to understand, but I'll go over it now quickly. So planted is if there's a plant on this plot, what time did we plant, how long till the time is complete. So we know 3600 is actually a full hour. I've just put 2, I'm not sure why. I'll change that to 0. We've got our stages. I've just -1 at the moment, so it's nothing. Obviously 0 is seed, 5 is completion. So this is called when we click on a plot, and that code is here. And it's just a case of saying, hey, have we left clicked on a plot? Is it inside the rect, which is inside the position of the plot? And if there isn't a plant, then we're going to plant one. And then to do that, we're going to get the planter, which is an auto load, and a planted seed. So let's look at the auto load quickly. What seed are we currently going to use? And this is updated every time we change this. So whatever text we have in here is what we're going to plant. So let's go back to our plant. So planted time is going to be OS get Unix time. Now this is going to be new for a lot of people, especially beginners. It certainly was new for me. So to explain this a little bit better, I've got a website here. What's going to happen is every computer right now has this. This is all our numbers are synced. So what's this number? So this number is every second that's ever existed from this time date. Thursday, the 1st of January, 1970. So as you can imagine, if I save this number on a plot when it's been planted, and then say 3 days passes, this number will be updated in our computer as well. I then minus the new number by the old number to get how many seconds have passed since we last planted. I'll show that in code a little bit later. So I changed the plot texture to farm plot 1, which is here, and it just removes the hole because we don't want a hole if a plant is in there. Then we change the values of the plant currently connected to our plot, which is this. And what we're going to do is just change the animation to the string name, which is passed through here, which is the option button. We then show it, then we set the frame to 0, which is seed. We then make sure that the plot knows that we do have a plant on here. If we go down to physics process, because we've just planted something, this is now going to be true. So we're going to do the growth logic. Now, as explained when we went over this, now to work out the time passed, which I said earlier, we're going to get the new Unix time and then minus it by the old one. This will return back how many seconds have passed since we planted this seed. Now I want to know how long each stage would be. So to do that, I'm going to plant completed time, which is 3600, divided by 5. This will calculate how long each stage is going to take. So if the current stage is 0, we just want to check that the time has not passed one of those stages. If it has, we update our current stage and we let them know the frame is increased, so it'll go to the sapling. else run 1 to 5. We only want to do this if we're not fully mature. Then it's a simple case of checking if the time passed is not past the current stage plus 1 by how long a stage is. If it is, we increase by 1. Then we update the frame to the current stage, so it goes as follows. The most important part of this is this part. This is the part that you can use in lots of different projects to determine how long time has passed since a certain event. Now, this do load will actually be called from the main when we load up our game. And what this is going to do is, using the saved file, is update this plot. So we know if this is true, then we've planted. So then we're going to do this code. So we're going to say planted equals true. We're going to set the seed name. What time did we plant? And make sure that we don't have the hole, and then show the plant. So let's go to the main. This is the saving and unloading part. So when we open the project, do load is called, but before we go over that, we're going to go over save. I think it's better to do save then load, it makes more sense. We're going to create an empty dictionary, then we're going to loop through every plot, and to do that we're going to go get nodes in group plots. So for each plot we're going to get the name, and then we're going to save an array to that name, and that will be the planted bool, the seed name, and what time did we plant. By storing this we can then load it in back later and minus it from our current Unix time to get how many seconds has passed. Even if it was a year, we would still know how long it would pass. Once we've finished every single plot, we open a new file. We then get fopen at this directory, which is here. Make sure you have that directory, else it won't work. So we're going to store a string, and what we're going to do is json.print save data. So this is a way of saving a dictionary into a JSON file. It's really useful. And then once we're finished with it, we just close it. Don't worry if this file doesn't exist, it will make it if it doesn't exist. Let's do load next. So this is going to be like save, but it's just reversed. We get the F as a new file. What we're going to do this time though is we're going to check that the file exists. If it doesn't, then we won't do this code. If it does, we know the file's there, so let's do the code. Then we define result, and we're going to pass in that JSON as a dictionary into the result. We're then finished with the file, so close it. So what we need to do is result.result. This is actually a dictionary. If the dictionary is not null, then we're going to do this code. Like with the save, we're going to loop through every single plot. We var data, which is going to be an array, and that's going to be the result.result I name. So we've just returned the array for that specific plot. Then we do I, which is our plot we're on, do load. That'll be our bool, that'll be the seed name, and that will be the time passed. So let's just go over it. So we've been over this code already, so I'm not going to go over it again. We've got one more script left, and it's just getting the label to our system clock. And it's a simple case of defining system clock, get your time, which is actually a dictionary. Then the text of the label, we just format the dictionary as follows into something that's more readable for us. And that's it for the code of the project. So for a demonstration, you might be thinking, well, 1 hour isn't that long to grow a plant, so what if you wanted to say 6 days? I'm going to need a calculator. We know that an hour is 3,600 seconds, and we know that there's 24 hours in a day, so let's times it by 24. So we know that this is a full day, so we want to times this by 6. It's going to be 6 days. Let's put that into our code. It's in the plot script, plant completed time. So let's plant some seeds. I'm going to plant too many, let's just plant some corn and maybe some tulips. Cool, so let's record the time, save this. Let's advance, say 2 days. As you can see, we've got some seedlings, so we can actually advance the days without having to close the application down. And there we go, full maturity. So that concludes the end of this tutorial. I want to thank you for stopping by. I want to recommend one more thing, is really research this, try to understand what does it mean, why have we got it, because knowing that really helps understand this project a lot more. So I hope to see you next one. Goodbye.